good. I have a lot of work for us. Now, the division of exponents is the second law of exponents. Okay, there are a few laws. So I'm going to write here. Oh, electricity's back. Din, 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 let there be light. Second law of exponents. All right. Now, this on the left explains to us why this law works the way it does. Okay, so if we are dividing, look here, if we're dividing 5 to the power of 7 by 5 to the power of 4. 5 to the power of 7 means there are 7 fives. Yes, 7 fives that you're multiplying with each other. So you're saying 5 times 5 times 5, 7 times. And at the bottom, it's 5 times 5 times 5, 4 times. Now, if you look at this, what's 5 divided by 5, guys? What is 5 divided by 5? Your answer will be 1. So these 5s are all just canceling each other and making a 1, right? See, first one, second one, third one. And then we are left with these guys over here. So 5 times 5 times 5 is equal to 5 to the power of what? That answer that is left over there is equal to 5 to the power of 3. Thank you. But instead of writing out all these 5s and taking the long way around, we could have just said this is 5 to the power of 7 minus 4, which is my second law of exponents. Okay, so if you are dividing powers with the same base, so remember NB, okay, must be the same base. Then you can just subtract your exponents as they have done over here with our x. So that is where and how, where the law comes from and how it works. Okay, so today we're going to be doing some of these, but I combined it with some of our rule number 1 or law number 1. So we'll be doing some multiplication with division, and then some of them are just division to make sure that you understand the concept before we get a bit complicated. I have some really interesting questions for us to do today. Okay, so we're going to start with number 1, 2, and 3, which I expect to go very quickly. Number 1, 3 to the power of 7 divided by 3 to the power of 4. That's 3 to the power of what? Remember, we're dividing, so we subtract my exponents. Thank you very much. 3 to the power of 3. Because you're saying 7 minus 3 minus 4. I'm thinking of 3 too much. 7 minus 4, so this will give us 3 cubed. And what's the value of 3 to the power of 3? Remember, if you can simplify, then do so. What is the value of 3 to the power of 3? 27. Thank you. Okay, we're off to a great start. Number 2, 5 to the power of 6 divided by 5 to the power of 9. My answer will be... Ooh, that is a mistake we all do. It's not to the power of 3. Check again. -3. So remember with this rule, the one at the top is always first in my sum. So it's always the one at the top minus the one at the bottom. Okay, or if they're side by side, it's the first one minus the second one. Always, always, always. The order matters, otherwise you will get different answers. And what's the value for 5 to the power of -3? Does anybody know? Thank you. It's 1 over 5 cubed, but we can still simplify. This is 1 over 5 cubed. 5 cubed is how much? Not quite. You're very close. There we go. 125. All right. Let's move on to our next one. Now we've moved on to variables. Okay, so we will not be simplifying. We will not be getting an answer, rather. Yes, Andilan, that is correct, because it is a to the power of 6 minus 14, which is a to the power of -8. Okay, seems like we're in the swing of things. Let's do 4, 5, and 6 quickly. Number 4. What's my answer for number 4, beautiful people? Which is equal to c to the power of 9. Beautiful. Now we're on number 5 and we have more than one base. How many bases that are different do we have? How many different bases do we have in number 5? 2. So don't make a mistake, okay? That was lousy highlighting. Do not make a mistake. There are 2 different bases. There's an N and there's a M. Okay, so in this case, only N can be subtracted. So it's going to be N to the power of 2 minus 1 at the top. Leave my M to the power of 3 at the bottom. It does not move to the numerator, okay? So my answer actually has to be N over M to the power of 3. Because remember, if you move it next to it, you're now saying it's N times M to the power of 3, which is incorrect. We are dividing. We have the same case in number 6, where we have X as well as Y. So how do we work this out? My answer will be what will be in the numerator? What will be in the numerator? Andile, that looks like you are multiplying them. You're putting them next to each other. It is x to the power of 3, but it is over y to the power of 4. Thank you. All right. Let's take a quick screenshot while I have a thumbs up, thumbs down on what we have done so far. Do we understand the concept of what we're doing? Thumbs up. Okay. If you are new, thumbs up means I understand. Thumbs down means I don't understand. Please explain again. Or you can ask a question, a specific question. All right. Now, let's see. Now we have 2 numbers that we are dividing, and that means we have to go back to our SNV rule. So we're going to start with the signs. We're going to go to the numbers, and then we go to the variables. Okay, so let's start with the signs. We are dividing 2 positive numbers, so my answer is going to be a positive number. Okay, now 3 goes into itself how many times? You can rewrite this if you prefer to do that, like so. X4, I think it looks better like that. 3 goes into itself once, thank you, and into 6 twice. And then in the numerator, I have x to the power of 6 divided by x to the power of 4. So then it's going to be x to the power of what minus what? X to the power of what minus what? It's a 4, it's not a 9. There we go. 6 minus 4 over the 2 that's still in the denominator. Don't forget that 2. So then my final answer will be what? Nice, nice. X squared over 2. Okay, let's see the next one. All right, if you got this in a test paper, where would you start? Where do you think we should start? By the division, says Senyani. Okay, divide, says Andile. Looks like we all agree. Do you guys think it matters where we start? If I started with multiplication, would it change my answer? No, it doesn't matter. Okay, as long as we know that it doesn't matter. But let's start with the division. Okay, 3 divided by 6. Again, we have a 3 and a 6 with a common factor of 3. So 3 goes into itself how many times? Nice, Pamantla already told me the answer. And into 6? Twice. So at the top, I have a 1. I'm not going to write it because it's not necessary, right? And then we have the x to the power of what minus what? X to the power of what minus what? 2 minus 1. And y doesn't have a partner, so I'm just going to write y. This is all over 2. Now I'm going to rewrite everything else because that's what you guys should do as well. Avoid putting questions in different sections and then putting them together. Okay, so this now is x, y, because 2 minus 1 is 1, over 2 times x cubed y squared. Right, now we are multiplying, right? Do you guys agree that this could be over 1? If you wanted to make it a fraction, you just put it over 1. Okay, so now we have my x's, which is that one and that one over there, and my y's, which is this one and this one over here. Right, so in my numerator, we are multiplying this time. So what do we do with my exponents? When we are multiplying, what do we do with the exponents again? We add them. Okay, so I have x to the power of 1 plus 3 and y to the power of 1 plus 2. Is my 2, this one, is it next to these or is it at the bottom of the fraction? Is my 2 next to them or is it going to be at the bottom? Seth says next to. Oh. Andile says next to. Demoho says at the bottom. Spamala says bottom. Everybody's opinion is scattered. Okay, guys, if I say 2x and if I say x over 2, are those the same thing? What's the difference between them? What's the difference between those two? No, thank you. Division and multiplication. So 2x means 2 times x. And x over 2 means x divided by 2. So if I put this 2 next to it here, will it mean the same thing as it did in this fraction? Am I allowed to just promote the 2 and put it at the bottom? No. So in fact, it's supposed to go back to the bottom. So then my final answer will then be x to the power of 4 times y to the power of 3 over 2. I hope we understand why we can't put it next to. Okay. Okay, I'm going to continue. I'm hoping everyone understands. Wonderful. Thanks for the feedback. Okay. Next. I must be nice and then I must be stern and then nice. So we're back to nice now. Okay. How many different bases do we see that are variables? So I'm not talking about the 2. How many bases do we see that are variables? Thank you, Seth. 3 of them. We have a B, and a C. There. Okay, so this will be equal to a to the power of 2 minus 1, because remember, if there's no exponent, there is a what? If there is no exponent, then the exponent is a 1. Beautiful, it's a 1. And then B doesn't have a partner. And then C to the power of what minus what? Nice. Mamalu is on a roll. C to the power of what minus what? 1 minus 1. And this is all over 2, which is at the bottom. So this will be a, b, c to the power of 0 over 2. But we know that c to the power of 0 has a value of 1. So this is saying ab times 1 over 2. And ab times 1 is just ab times 1 is just ab, right? So then the answer is ab divided by 2. Jason, I can actually rename you quickly. There we go. Now I can speak to you, refer to you guys with your proper names. Okay. I don't know why there's sudden noise outside my window. Don't mind it, okay? Now let's get to this one. A little bit more interesting. Where do we want to start in this case? Where do you guys want to start here? Seth says multiply, I'm assuming. Okay, you want to start with multiplication. Okay, let's start with multiplication. That means we have to multiply these two guys together, right? Yes. So at the top, I have an x cubed. I need more colors than these ones that I have here. I need to update. We have an x cubed and an x at the top. And that's the only common ones we have at the top. So then, since we are multiplying, what are we going to do with my exponents? We're going to add them. So it's going to be x to the power of 3 plus 1. Okay, I'm going to put the 6 there. And then y squared all over. Which variable can we add in the denominator? Which variable in the denominator? Thank you, Seth, a y. So I'm just going to write 3x because we can't do anything about them. And then it's y to the power of what plus what? 1 plus 1. And then I'm going to write divide by 2x on the side equals. Now let's simplify quickly. X to the power of 4, y squared, 3xy squared divided by 2x. Nice. Where are we going next? Where are we going next? Divide the fraction. All right, Seth, let's start with my symbols. They're both positive, so I'm going to have a positive. Let's go to numbers. What is my common factor between 6 and 3? 3. 3 goes into itself how many times? Once, and into 6 twice. Okay, we're done with the numbers. Done with the numbers. So we have a 2 at the top. Okay. X to the power of 4 divided by x. So then it's x to the power of what minus what? It's 3. Thank you, Senyani, because it's 4 minus 1. And then y to the power of 0. So let me simplify it quickly to the ones that you guys taught me. So this is x cubed, y is 0 divided by 2x equals 2. No, we're dividing. I seem to be forgetting that we're dividing. Start with symbols. They're both positive. So my answer is positive, right? What is 2 divided by 2? It is 1. X cubed divided by x. So it's going to be x to the power of 2. And then y to the power of 0 is the same as? Nice. So then my final answer is 1 times x squared times 1, which is 1 times x squared times 1. It is x squared. Beautiful, guys. That was beautifully done. Hopefully, I didn't lose anyone along the way. Hopefully. Okay, this one is too easy for us in here. So I'm going to take this one. At least it has a different symbol, right? We've been working with positives this whole time. Okay, we start with our symbols. A negative and a negative will give us what type of number? A positive. 6 and 2, what is my common factor? It is 2. It goes into 2 once and into 6 3 times. Okay, so we have positive 3. X cubed divided by x. So it's x to the power of 3 minus 1, which is 2. Y squared divided by y cubed. So it's y to the power of -1. Now, I know we haven't done negative exponents yet, but does anybody know what we're going to do with this -1? This y to the power of -1. What are we going to do with it? How do we change it to a positive? Nice. Everything over y. Nice, Pamandla and Senyani. So then it's going to be 3x squared over y. You guys are brilliant. Nice, Kale. Okay, here's my next one. We have a situation there with the negative y cubed, which means negative y times negative y times negative y. And my answer to that would be what? Seth says y cubed. Okay. So does Andile. A negative times a negative times a negative. Thanks, Leachilwe. This is negative y cubed because there are 3 of them. Okay. Close one. Now, if I am putting a negative y cubed next to the 9, 9 times a negative will give you a what? Positive 9 times a negative? Negative. So my whole numerator is actually negative 9y cubed x squared. And this is all over. Oh, that was a terrible line. This is all over 12yx cubed. Okay, now if I'm dividing a negative and a positive, my answer is going to be negative. How did we get negative? Kale, it was negative y times negative y times negative y, right? And we said the answer is negative y cubed. Now, if you look in the numerator, this means it's 9 times negative y cubed times x squared. This is positive times negative. What does a positive and a negative give you? A negative times another positive. Still a negative. Do you see why the whole numerator is negative? I hope I answered your question. There we go. Okay. All right. So we said my whole answer will be negative. What is my common factor between 9 and 12? 3 into 9. 3 times. And 12. 4 times. So I have a negative and I have a 3 over 4. Okay. Y cubed divided by y. My new exponent for y is now y squared. And then x exponent. If I say x squared divided by x cubed, it's x to the power of -1. But what can we do to this x to the power of -1? We can bring it down to the 4. So my final answer is 3y squared over 4x. Nice. I haven't had a check-in a while. Thumbs up, thumbs down. Are we all good with this one? Okay. Wonderful. Okay. Great. Let's have a short brain break, a quick one. Would you rather sneeze every 3 minutes or always have the sensation to sneeze but never do? So you either sneeze literally every 3 minutes, or you always have a sensation to sneeze, but you can't sneeze. Sensation, guys, that sensation is torture. It is absolutely terrible. I know, but sneezing is worse, especially every 3 minutes. Especially every 3 minutes. Okay, the next one. Would you rather spend 5 years in prison for something that you did not do, or 10 years for something you did? Renewa is the same as me. I wouldn't, guys, 5 years for nothing, basically. I'd rather go 10 years knowing I did something, you know? And like 5 years just because, yo, just because, nje. I'd rather do the 10 years. It's shorter, but for someone who did absolutely nothing, it is terrible. At least with the 10 years, you sit there like, Shem, I know what I did. I deserve it. It's fine. Whereas with the 5 years, our guys, yo. Exactly. I would also be mad. How do you get over that? Our guys. Would you rather be an amazing artist or a brilliant mathematician? Because Jason says mathematician. Wow, there are more mathematicians than I was expecting. Amazing artists, talented people. Nice. And the last one, would you rather win a 2-week vacation or a 1-day shopping spree? I would rather go on a shopping spree where I can buy plane tickets and pay for my vacation. That's part of a shopping spree. They didn't say you can't buy a vacation. I would definitely buy a vacation. I would pay for a vacation. I'm being honest, Seth, think about it. They never said you can't pay for or buy tickets for a vacation. So I would choose a shopping spree. And then I'll pay my vacation. And then I also, on top of that, buy the stuff I want. Ah, wow. Okay, guys, are we ready? I'm gonna have a short stretch here. I feel like I am absolutely crumbling where I'm sitting. Oh, let's have a stretch. Pamanda says Lotus. Pamanda, are you blessing me? Maybe I should go and try the lotto tonight. Maybe I'll win. Pamanda is busy there blessing me with blessings for lotto. Okay. Excuse me. Oh, I'm so tired. All right, let's do more interesting sounds. Okay. How about we do more interesting ones? We're going to start with A, which is not that bad. Then we'll work our way up from there. For A, how many different bases do we see? 3 billion. There's a 5 and there's a 3. Okay. Let's start with the multiplication. Okay, so at the top, I have 5 to the power of 7 times 5 to the power of 8. That's going to give me 5 to the power of what? 15, thank you. And 3 to the power of 3 times 3 to the power of 6 is going to give me 3 to the power of 9. Done with my numerator. Let's go to the denominator. 5 to the power of 20 doesn't have a partner, so I'm just going to write it. Times 3 to the power of what? 8. Okay. Now we still have our two separate bases. Here's my 3 still. And here is my 5 still. So then 5 to the power of 15 divided by 5 to the power of 20 is going to give me 5 to the power of -5 times 3 to the power of 1. So I'm going to rewrite it the way we like to rewrite it. I'm going to put this over 5 to the power of 5. So then what will my answer be? What will my answer be? 3 divided by 5 to the power of 5. My answer is, anyone? No. Remember, if it's numbers, then you can simplify it. There we go. Okay, I'm going to write the fraction version, which is 3 over 3,125. Okay, remember, if it's numbers, guys, you always simplify. Okay, Spamandla? Yes.
Ma'am, could I ask a question?
Mm-hmm.
If in the test say that if they say in the test you must simplify, or they don't say you must simplify, do you still have to simplify the answer when they don't say simplified fully?
Yes. If it's numbers, then yes, you have to simplify it. Obviously, if it's a variable,
Oh,
you
yes,
can't do anything about it. But if it's numbers, then
yes.
yes.
Okay, ma'am.
Good question. Okay. What happened to the exponents of -5? We made it a fractions, and remember, 5 to the power of -5. I'm writing with my eraser. 5 to the power of -5 is the same as 1 over 5 to the 5, right? So we basically said 1 over 5 to the power of 5 times 3, which is how this 3 ended up there. Did you see? Do you understand? There we go. My teacher said if the bases are not the same, we must leave it as is, including numbers. Was that including numbers, or was that for variables? Like if you have an A and a B, because then you cannot do anything about it. It's for the variables. But when it's numbers, try to simplify as far as possible. I know, because when I mark my maths papers, I like it when my kids just simplify. But check for me quick, Seth. But if your teacher has that preference, then just leave it like that. I just don't want you guys to lose a final mark because you stopped somewhere in the middle of the road, right? It would be sad if you got everything right, you did this right, that right, but then you don't simplify, and then they take away a mark just because you didn't simplify. Okay, so just to be safe, simplify. If she doesn't want the last step, she can't take away a mark. Do you guys get what I mean? She will just mark until here and then stop. But if this last step is allocated a mark, then you're going to lose it. Do you understand what I mean, guys? If you stop here and she wants the last step, you're going to lose the mark. But if she doesn't want the last step, she'll just mark until where she's satisfied. For instance, she'll mark there and there and there and then stop. She cannot take away marks because you simplified. That's not allowed. Okay. Seth says with number. Seth, did you hear what I said? If she has a preference, then that's fine. But for most teachers, I would say write until you cannot simplify any further. Because if she only wants these 3 marks, you're going to get them anyway. But if she wants the 4 and you only stopped here, you're going to lose a mark. All right. Okay, there's my nice, interesting one. All right, let's check numbers. Are there any common factors with my numbers here? Are there any common factors with my numbers? Yes, between what and what? Which 2 numbers or 4 numbers or whatever have a common factor? 3 and 2 don't have a common factor. 3 and 6 do. What is the common factor between 3 and 6? As well as 4 and 2. Common factor is? Okay, there's a lot going on. What is the common factor between 3 and 6? 3. Thank you, guys. 3 goes into itself how many times? Once, and into 6 twice. Okay, let's do the 2 and the 4. 2 goes into itself once and into 4 twice. But look what's going on here. We have a 2 at the top and at the bottom. What can we do with these 2's? What can we do with these 2's? It's 2 divided by 2 basically, right? They cancel out. So this 2 once, that 2 once, gone. All the numbers are gone. All right, so let's rewrite what we have left. We have x squared times xy to the power of 7 over x squared y times x squared times y. Okay, I want to see if we can do it all in one swoop. So what I mean is multiply and divide at the same time. So I'm going to write here x. Let's start at the top. It's x to the power of 2. What are we going to do with this exponent here? Plus 1. And then at the bottom, this one. Remember, we are dividing. I'm doing them in one step. I want to show you that you guys can do it in one step. So it's 2 plus 1. Thank you, Seth. Minus 2 and minus another 2. Is there anyone that I just confused with that step before I move on? Is there anyone that might need more clarification of what we just did there? Okay, we all did it in one step, okay? Remember, when you are adding, when you're multiplying, excuse me, you add. So you say 2 plus 1, which is over there. And then we go to divide. Divide means you do what to the exponents? We subtract. So then you go minus the ones at the bottom, the ones you are dividing. So it's 2 plus 1, which are on top, minus the first 2 that's at the bottom, minus the second 2 that's at the bottom. Do you guys see what I did there? You do not have to do it one by one. It's fine if you like it. I just wanted to show you that you can do it all in one step. Okay, and then y at the top is just 7. So what are we going to do with the exponents at the bottom? Nice and delay, minus 1, because we have 2 ones at the bottom. And then this will give us what? X to the power of, what's 2 plus 1 minus 2 minus 2? 2 plus 1 minus 2 minus 2. It's negative 1. And y to the power of 7 minus 1 is 5. And then we can just simplify this by putting it in fraction mode because of the negative exponent. See, guys, if you like step by step, that's fine. I just wanted to show you that you can do it in one step. It's definitely less steps than if you did it step by step, but I love step by step because you do not make mistakes when you do it step by step. This one could trip you up a little bit. Okay, I have C and D. Let's do number C. Number C is very interesting. And then we're going to do D just for our brains to cool off before we go. Okay, where are we starting with number C? Where do you guys think we should start? Two. What are we going to do with this two? Tally says fractions. Sinyani says times. Umpa says left to right. Would you get the same marks? Yes, you would, Seth. This is how I would mark it. Okay, I would mark the addition part, the subtracting the first one, and subtracting the second one. So instead of the 3 steps, I would just mark where you did it. Then here as well, I would mark over there and over there. You see what I mean? You would absolutely get all your marks. Okay, let's start the fractions. I think that's the easier part to start. 7 and 14, do we have a common factor? Which is 7. It goes into itself once, and into 14 twice. Nice. 18 and 6, do we have a common factor? 6, thank you, Andile, goes into itself once, and into 18 3 times. Wonderful. Okay. So I'm going to leave this 2x squared y here since we're working in the fractions. Times. Now we have a 1 at the top. We don't have to write it. It's going to be x to the power of what minus what? Well, on my second fraction now. So it's going to be x to the power of what minus what? 2 minus 3. Times y to the power of what minus what? 5 minus 1, all over 2. Remember, there's still a 2 chilling there. Times, this is just 3x over y. Okay, now where do we go? I'm simplifying. I want you guys to tell me now where should I go with this. What's next? We don't have any fractions that we can simplify anymore. I'm going to take someone's suggestion who said we must go left to right. So let's start with these two guys over here, right? 2 times, if there's nothing in front there, what is it? It's a 1, so it is just 2 times x to the power of what plus what? X to the power of, there we go, 2 plus negative 1 times y to the power of what plus what? 4 plus 1. Then we still have times 3x divided by y. Okay, this guy's going to take space. 2x. That plus minus creates a negative. So it's 2 minus 1. So it's just 1. So it's just x. And then we're going to have y to the power of 5 times 3x over y. Okay, let's multiply now. Numbers, 2 times 3 is 6. I have an x and an x, so that's going to be x to the power of what? X squared, y 5 all over y. Can we still simplify something? Yes, we can. What can we simplify the y? So we have y to the power of 5 over y to the power of 1. So then my y final answer will be to the power of 4. And that is my final answer.